Hello ladies and gentlemen, and welcome to our today's Innovation Coffee Break. Compared to our on-road applications, it will be more dusty, more heavy, larger, darker. Anyway, in the next minutes we will talk about off-road simulation, a field of diverse use cases with many interesting technical requirements and problems. So the right stuff to have a coffee break about. My name is Norbert. Let me guide you through our experiences in this topic. What is the mission to be completed? We are often contacted to provide off-road simulation solutions. Speaking with X different customers in the off-road area might bring X different use cases. There are applications out of the construction and agriculture sector having a closer look on autonomous working sites. Vehicle manufacturers having a closer look on off-road dynamics. But it doesn't need to be someone out of the vehicle context. Off-road or off-highway attract also use cases dealing with robots, even indoor, boat, trains, a universe of different domains. All of them interesting, all of them with their own technical finesse. That's why I love to talk about it. But hey, where are we coming from? Okay, a lot of activities and the historical starting point of our simulations are based in the on-road automotive sector, as shown in this video. But aren't we able to use our energy from the on-road expertise to the off-road domain? Let's see. What is our set of products to simulate vehicles, sensors, and the 3D environment? Yes, it's ASM and AURELION. So this is our toolbox to tackle the simulation demands. But before speaking about our role to provide adequate answers, I will briefly introduce the tools in our toolbox. ASM, Automotive Simulation Models, provides a modular simulation suite, completely open by relying on Simulink, giving you maximum traceability and insight of the simulation behavior. Made for real-time simulation and faster non-real-time in-the-loop use cases. Maybe just looking on the vehicle domain, a vehicle simulation able to be adapted to customer demands, having a calculation-efficient multi-body simulation approach, which is open for articulated components, is a solid start. With all the relevant physical components in the vehicle, including a soft ECU network, we found out that we have a great base for closed-loop applications besides the road. Showing here a subset of solutions which have been delivered in the past to show what automotive multi-body packages can already provide in the off-highway domain. Let's take the vehicle dynamics package. For a four-wheel, two-axle driven vehicle. This was taken to simulate wheeled excavators or off-road capable vehicles. Take the truck package in case of additional degrees of freedom. In the ego vehicle, multiple axles or twin tire applications, as we find them in mining applications here. These packages can easily be extended with trailers due to our articulated body algorithm. If this is not enough, it's no problem to add or exchange subsystems of the vehicle. Take here the auxiliary equipment like forklift or articulated arms, which might need to be added in the off-highway project. Coming from the vehicle multi-body simulation to our other tool, AURELION. AURELION as an Unreal-based 3D environment, giving you not only the possibility to have a nice view on the current simulation status of the vehicle. In your scenery, it is mainly intended to open the space for ray tracing-based sensor simulation. Which sensors are available? Of course, it's the radar, the camera, and the LiDAR. Together with these, also solutions for ultrasonic sensors are available. Here are a few facts about our simulation features, which are also relevant for your off-highway application. Let's take the camera. For this passive sensor, you must simulate the environment, the lens, and the imager of the camera. Physically based rendering makes the materials in a 3D environment as realistic as possible. Calculating the lens distortion before traveling to the imager is as important as respecting a target color filter. In case of the radar, you can parameterize your TX and RX antenna. A fully polarimetric simulation respects horizontal and vertical oscillations for different radar types, ghost targets due to multipath reflections, and so on. And last but not least, LiDAR, with its parameterizable scan pattern, if it's flash-based or scan-based. In the latter case, also motion distortion is considered due to superimposed movements. Anyway, there are a lot of features in AURELION which can directly be applied to your off-highway environment. Just define the correct scene, get the correct car, and switch on the sensor simulation. But let's leave the sensor details now coming back to our question, to our mission. During the last minutes, we got a common understanding of our portfolio. And it seems that there are a lot of useful features already available away from the streets. But which puzzle pieces need to be found? Which parts are missing? I will give you an insight. Starting with 3D environment simulation aspects. Of course, in the beginning, we started to combine ASM with an off-highway scene in AURELION, here a mining scene out of South America. Having this, it is clearly obvious that our engineering as well as the customer need to be able to work with the 3D scenery, as off-highway scenes are very individual depending on the industry branch, the architecture of the construction site, type of vehicles. So deploying online tutorials is a very good starting point. Besides this, we have ongoing internal proof of concepts to get own impressions and to enlarge our asset portfolio with 3D content like mining scenes or wilder rocket forest type of environments. And last but not least, working in customer projects with our own engineering delivers continuously requirements for real-world use cases. Moving on to the side of the vehicle simulation. Quite obviously, someone needs to think about the wheel-underground interaction. As shown in this video, we worked out real-time capable solutions for soft soil modeling, integrating a normal and shear stress model and combining this with models for the underground and elastic tire provides a good basis for compressing the terrain and deflecting the tire. On the other hand, you will find tracked vehicle applications from various industry, starting with chain-driven dynamic model and combining this tracked vehicle with soft soil simulation. Hence, working out the contact point pressures, determining the line loads, the corresponding track line, a very interesting topic where real-time capability is a crucial point, as you have not just the dependencies between the contact points due to the track. It is also the number of contact points describing the track line, which influences the calculation effort a lot. Finally, you need to think about the correct storage of terrain data in the simulation. Triangular irregular network data out of a 3D modeling tool with its information on varying terrain properties need to be processed as shown in this video. Not everything is possible out of the box now, but you see, we made a lot of progress, a lot of experience. So let's speak about your requirements to get things running in a project and to fit our future tools to your use case. So, ASM and AURELION are already having the missing puzzle pieces in mind and serves as a good basis to complete the puzzle. At the end, let's have some fun with videos, giving you further impressions of our current capabilities. Indoor scenes away from ordinary roads like car parks, okay, is still very automotive, logistics, or even mining in underground situations. All of them have a common effect, the effect of complete artificial lighting, which need to be replicated as best as possible for plausible sensor detection. Here you also see multiple sensors in your scene, as it might not just be your ego vehicle having a sensor mounted. This is not a problem for AURELION. Please also have a look on the color coding of LiDAR points which reflect different materials in the scene. Moving from indoor to outdoor. Watching here a deformed terrain in an excavator scenery. In ASM, the complete multi-body dynamics of the vehicle is being calculated, resulting in the movement as shown here. The wheel-underground interaction has been extended for soft soil as explained before. In the technical figure, the underground deformation is depicted. This already shows a lot of potential in the field of construction and mining site simulation. From a working situation to an off-road driving enjoyment. In here, you can also estimate our potentials of ASM vehicle and AURELION sensor simulation in an off-highway scenery. Use cases like these might also be interesting for vehicle dynamic investigation, including terrain detection and adaptation in ride comfort. Coming to the end of our coffee break, by remembering the initial question, mission possible? I would say mission accepted. With ASM and AURELION, we have tools available at dSPACE, which already covers a wide variety of off-road demands and serves as a great basis for making further progress and experience in upcoming projects with you. So, let's get in touch, visit our digital platforms, contact us, and get your use case off the road. Thank you very much.